Welcome to ClickMyProject.com. Our project title is the first text placement scheme for ASCII synthesis. This is our abstract. This project proposes a method that converts a binary picture into ASCII art. Our method uses the multi-threaded local optimization for a text replacement method rather than a global optimization in order to make a ASCII art quickly. The original image is first transformed into a thin black and white image appropriate for making the ASCII art. In order to create the ASCII art for the diverse images, then we take the input images pixel orientation and extract them before introducing the character similarity scheme that takes them into account. We also provide a fresh text insertion algorithm to quickly finish the ASCII graphics. Last technique we provide here, we can produce ASCII graphics in a wide range of proportional typefaces. Here uses the dataset contain the two classes. Dataset preprocess all the images and combine into two classes and use the deep learning method to classify them, and also use the ML to compare the accuracy. ASCII generation is mainly used to produce the images ranging from simple and functional emotions to the elaborate work of art. This is our objective. Create a fast ASCII generation technique, improve the accuracy, deep learning algorithm for the classification, most advanced library for the text conversion. This is a system architecture. First we have a data set. From the data set we want to select the data. Next step is the pre-processing. Pre-process all the images in the data set and then split the data according to the feature extraction and classify the data using the algorithms like CNN and SVM. And then after classification we want to predict the images. For the prediction, first we want to select the image from the data set and then convert the image to the grayscale, and then to define the ASCII character, ASCII generation. After the ASCII generation we want to find the performance analysis, SSIM, MAE, and then MSE, and then PSNR, and then RMSE. This is a flow diagram. We collect the data in the data set. It's a image data set. Select the image and pre-process all the image and data splitting according to the training and testing data as the ratio 8:2. And then feature extraction and classification, we want to apply the algorithms CNN and SVM. And then prediction, here we want to select the one image and then image is converted to the grayscale, and then define the ASCII character. We want to convert the image into the ASCII art. Finally we calculate the performance analysis of this image, MSE, PSNR, and then MAE, and the SSIM, and then RMSE. And then this is a use case diagram. From the user point of view, first what are the modules in the data selection, and then pre-processing, splitting, feature extraction, classification, performance analysis. This is ER diagram. First we start our program and load data set, select the data, pre-process it, and then split the data and extract the features among them, and then classify using the algorithms, performance analysis, and find the parameters for the images. And then sequence diagram. We want to split the sequence as 4. First one is the starting, then second is the pre-processing, third is the classification, final is the performance. First, when we start it, we want to select the data and load it, and then in pre-processing stage we want to pre-process all the images as in this resizing, and then remove noise, filtering, and then in classification apply the algorithms, and then performance analysis calculate the parameters. After executing our process, first one is the ML algorithm, SVM classification. accuracy is maintained as the 98, and classification report for our data set, that is a precision and recall and F1 score and support. And then this is a confusion matrix, and here is our confusion matrix. And then this is our, we select the input image from our data set. We want to convert into gray, as well as in the RGB image, and then inverted image for this. And then we want to apply some Gaussian blur, and then inverted. After the Gaussian blur noise, we want to convert the inverted, and then our ASCII art is generated like this. Then finally calculate the MSC value and PSNR value and MAA value and SSIM value. RMSC value is calculated for the image.